Okay, so I think the problem you have here was, let's see, negative 7x minus 1 is greater than 20, or negative 6x plus 7 is less than 1. Okay, so in order to solve this system of inequalities, we want to isolate x in each case, and then we'll combine the answers. To isolate x, just remember that if you multiply or divide by a negative in the process of solving, then you have to reverse the direction of the inequality. So if you multiply or divide by a negative, must reverse inequality. Okay, that's just one thing that students sometimes forget. Okay, so if it's greater, it'll become less. If it's less, it'll become greater, etc. Okay, so let's begin to isolate x here. So I'm going to add 1. So that's pretty easy. Negative 7x is greater than 21. Now I'm going to divide by negative 7. And as soon as I do that, a little bell should go off. Ding, 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 right? I'm dividing by a negative, and so I'm going to scratch this guy out and go the other way. All right, so we end up with what? We end up with x is less than 21 over negative 7 is negative 3. Okay, now let's work on the next one. Okay, so I'm going to subtract 7. Now subtraction, is negative, but it doesn't matter. It's multiplication or division by a negative that we have to watch out for, not subtraction. Okay, so in this case, I'm going to have negative 6x is less than, let's see, 1 minus 7 is negative 6. And now I'm going to divide both sides by negative 6. Okay, and a little bell should go off, right? As soon as I divide both sides by negative 6, ding, 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 right? I'm dividing by a negative, so I have to reverse the direction. Okay, and so I end up with, let's see, I'll go with a different color here. We'll go with the light blue. We end up with x is greater than 1. Okay, now to combine these, the way I like to combine these is by using what I like to call number line diagram. So I'm just going to draw a number line for each of these figures, and then we'll line them up. Okay, so I'm going to sort of put negative infinity out here, way at the left. I'm going to put infinity over here. And now for the negative 3, here's negative 3 on this guy. Okay, here's 1 on this guy. 1's to the right of negative 3. Now, x has to be less than negative 3. Okay, so that means that I'm going to shade everything out to the left this way. Okay, I'll put an open circle at negative 3 because I can't equal it. I can come up close to it, but not equal it. That's why it's a strict inequality. Now, if it had an equal sign, I would fill in the circle, and I could be exactly at negative 3. But because there's no equals, I can just come up to it and not quite touch it. Okay, now, for this other inequality, x greater than 1, again, open circle at 1, because I cannot equal it, and then greater than means to the right. Now, how do we combine these two diagrams? If it's an OR, and this is really neat, that's why I like the diagram method. For OR, you just sort of like add the two together. Add the two regions together, because either one will work. Now, if this was an AND, for AND, you only look for the overlap. You only take the overlap. Whoops, only, sorry about that, only take the overlap. Okay, in this case, we have an OR situation. Okay, so I can take both regions. So I'm going to have, now how do I denote the regions? Basically, just kind of mark down your endpoints. My endpoints here are negative infinity, negative infinity to negative 3 for this piece. This piece is going to be from 1 to infinity, and we're done. Just put a union between them, and you're finished. Okay? Now, what if it was an AND? If this problem said AND, which it does not, but if it did, if it said AND, the answer would be does not exist because there's no overlap. You would only take the overlap. Okay? So I kind of like this number line method. Let me try another problem. Okay? Okay, so here's another example with OR. Okay, so again, we're going to isolate the x, remembering our rules about reversal of the direction of the inequality if we're multiplying or dividing by a negative. So I'm going to add 3 to both sides. Okay, so 7x less than or equal to negative 14. Then what? Let's divide by 7 on both sides. And again, we're not dividing by a negative, so we do not have to reverse anything. So x is less than or equal to negative 2. Okay, now let's go with our next inequality here. Let's see, I'm going to subtract 2. And so I've got negative 5x is less than or equal to 25. Now let's divide by negative 5. Do you guys hear the bell? I already hear the bell. Ding, 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 right? What's the bell say? Bell says I just reverse the direction, right? So I'm going to pivot, reverse the direction of the inequality because I've divided by a negative. Okay, and so we end up with x greater than or equal to -5. Okay, so, and let me just put this in blue, I guess, so it stands out. Okay, so now let's combine these in a number line. Okay, so I'm going to draw a number line for each inequality, and then we'll combine them. So what do number lines look like? Looks like a line, right? We always label negative infinity at the left, positive infinity at the right. Do another one. One of them for each of the inequalities that we're trying to combine. And let's see, what do we have? We've got x less than or equal to, so where's -2? -2 is to the right of -5. You have to get the order correct or the method will not work. -2 is to the right of -5 on the number line, right? 0 is out here somewhere. -5 is more negative than -2, so it's further to the left. So less than or equal to -2, which that means I'm going to shade which way? I'm going to shade to the left of -2. And I can also include -2 itself because it's an equals sign. It's what's called a relative inequality, not an absolute inequality. It has an equals. Okay. Now, how about the -5? I'm going to shade to the right of -5. Okay. And now we want to sort of look at look at all the locations that are in one shaded region or the other. Okay. So what is in one shaded region or the other? For example, let's make a third number line now just for the result. In this case, it might be kind of helpful. So here's my result. So for example, let's say -6, is that in one or the other? Yeah, it's right there. So it's in one of them, so that's part of my answer. How about -5? That's actually in both of them. So it is in at least one of them. That's part of my answer. -4, yes. Okay, -3, -2. In fact, all this stuff's in there. It looks like, because think about like shining a light down from above. Okay, I'm going to get shade here from the first one, from this guy. I'm going to get shade here from the second guy. And so basically I'm shading in the whole number line. So my result here is -infinity to infinity. All real numbers will solve this system. All real numbers are either going to be in this solutions to this or the solutions to that, or both. Some will be in both. Okay. Now, what if it was an and? What if I switch this to an and, just for practice? Okay, if you like practice. If I switch this to an and, what happens? Then I have to be in the overlap. So then, for and, that would be my solution. The solution for and would be from -5 to -2. Right? Okay, so this sort of number line notation is very good.